This is Peter again, and at this point, thanks to those of you who are joining us live, and we're going to be eager to turn to your questions. Again, at the bottom of your screen for this webinar, there's a Q&A box, and you can use that to type in your questions. First, I've got a couple that I jotted down from the chat box while we were presenting here. So the first question, I think, probably is going to be best for Mario to answer. And it's a question from David. Probably not our David, but he's asking about the section that we presented on hash-based signatures, and he's saying he's got a lot of expertise in blockchains and cryptography, but he's never heard of Lamport or Winternit's Watts plus signatures, and so looking for more context on that, and I guess maybe a way to approach that would be, is there an analog to these in more common blockchains? What would be the more familiar version of that?
Absolutely. So basically, traditional blockchains, they use elliptic curve signatures, right? So you can commonly find either ECDSA, which is basically just you're essentially using your private key, you perform an operation, and you end up with a signature on the curve. So like this operation here is not quantum secure. So in the 80s, if I'm not mistaken, Lamport designed the system based just on hash functions, relying on the property that as long as you have one-way functions, you're actually able to sign any type of message. So we kind of found like the equivalent for here, instead of a message, it's an actual payment transaction. The Lamport scheme that we showed is secure as long as the function is one way. And here in this case, we're actually signing bit per bit. So you end up having, for example, if you're signing a normal message of 256 bits, you're releasing 256 secrets of 256 bits. The signature gets very big. So I don't know if there are any other questions that if you would like me to expand more on that, but essentially it's just a normal signature scheme that allows any party to digitally sign a message in a quantum secure manner. And these are one-time use. Why? Because it's a hash function. The moment you release your secret entry, you already compromised a lot of your secret keys. So if you were to try to sign more messages, you would essentially be decreasing your security on every time you sign, which is not ideal in a cryptographic world.
Great, thanks, Mario. And again, if folks have follow-up questions, please use the Q&A dialog box here. There's another question that I think Will would be the best to answer, and this is from Kiosa, who was asking about the NodeCon section. And so the question is, how much does NodeCon scale? Is this something that is limited, similar to how the Zcash trusted setup works, or what are the parameters around that?
Yeah, so it's actually a very good question. There's actually a number of answers here, and it depends on the exact approach we take to NodeCon. I will say we've designed NodeCon to be able to accommodate. I mean, we've actually kind of literally built some of the infrastructure and the technology you would use at NodeCon and tested it out. We're pretty confident that we can support sizes of over 100 node attendees. Just for the initial kind of launch or initialization of the network. And then we have ways to obviously hold multiple NodeCons, combine the results of those. And then we also have a way to immediately expand the network following NodeCon using some virtual methods, which, as long as you've initialized the network securely in the physical sense, all the virtual expansion will be as similarly secure as the initial primitives that were generated. So these are like the authenticated channels between each node, and also the quantum secure random seed. All those will remain just as secure, but then you're able to upscale the network to thousands of nodes almost immediately. We didn't get a chance to talk about that virtual expansion. As you can see, we were tight on time as it was, but we can expand on this later on. But yeah, I mean, we're expecting to be able to support at least 100 per NodeCon, and possibly even more. Just it depends on the resources we have.
Great, thanks, Will. And I'm noticing that Byron has another question about NodeCon. where he's asking roughly how many random seeds need to be produced before NodeCon, and what does that look like for a node who's going to NodeCon to bring all these randoms?
That is an excellent question. If I could find that exact question. I don't remember exactly what he asked. I will say, in general, producing these seeds that you're going to be using both at NodeCon and throughout consensus, obviously you're only generating a finite number of these commits. You're going to run out eventually, as consensus goes on. This has to do with that virtual expansion protocol that I mentioned in the last question. That same protocol is actually used to recommit nodes to new placards in parallel with consensus. So periodically throughout the operation of the network, you'll have something running in the background. We internally call it VertCon. It's the parallel to NodeCon. And this allows you to, add new nodes to the network in a secure way. It allows you to form new authenticated channels between those new nodes and the rest of the team, or the rest of the network. And it also allows you to recommit to these randoms that you've generated, a new set of randoms that you generate. But to answer a question kind of about how many of these randoms you need to bring to NodeCon, I can actually release, probably in the near future, a blog post or something that goes into exact detail, every step of NodeCon, exactly how many node randoms you need to bring. We have two methods of doing this, either digitally or physically. One way is literally kind of printing out QR codes, sticking them on cards and bringing them with you. In this way, you might need to bring, it depends on how many nodes come. So if say, 200 nodes are at NodeCon, then you need to at least bring 200 QR codes for each of those nodes so that you can share authenticated channels with them. And then you need to bring a handful of them to generate the secure random seed. And then you need to bring another few if we do a physical signing of the Genesis block. And there are a couple of reasons why you might want to do it in a physical way, so you don't rely on trusted servers to exchange this information where you haven't had a chance, or maybe you're just not experienced enough to vet the code in those servers. So this is a way that anybody, despite regardless of your expertise level or your experience with computers, you're able to kind of vet this process and be confident that everything's been done securely.
Great, thank you, Will. Next, there's a couple of questions about the XX communication layer. And so I'm going to hand the microphone over to Ben to answer those.
Hi, so we've been asked, there's an interesting conversation that went on in the chat about the gateways and how message delivery works, and if that has any implications to anonymity. So the answer is fundamentally yes. The gateways who receive messages can see who they came from, and the gateways who deliver them can see who they went to. But the knowledge connecting sender to receiver is associated. The other important point is that the gateways don't have a complete propagation of every message in the network. Messages are located only a small number of gateways and can only be retrieved from them. What this means is that while gateways might know that at a certain time a user received a message, that will only be a small fraction of information required to know what messages they received in their entire communication pattern as well as their sending pattern. This is pretty important because once you have the breaking of sender to receiver, the primary mode of attack on these networks are these statistical analyses. And the fact that each gateway only has a small subset of received messages and sent messages makes it very difficult for them to execute statistical analyses of what was received and what was sent, and kind of how an individual user operates. Of course, it's important to note that we're assuming the network's adversary is what's called a global adversary, meaning that adversary can see every packet sent and received by every single server and client on the internet. And once you make that assumption, you have to assume that this attacker can see who sends and who receives but just not see inside of the nodes themselves. So it really is, it doesn't break the fundamental adversarial model that the network is using. It is generally used for these types of anonymity systems. There was another question about how difficult would it be to implement voice messaging, video conferencing, and/or self-destructing messages? Are these feature in the plans at some point? So CMIX is is quite fundamentally it's an anonymity network designed to deliver with prioritizing privacy, and as a result, bandwidth is somewhat constrained. So voice messaging is feasible, video conferencing is less than likely. As to self-destructing messages, the self-destructing messages actually have some cryptographic issues, meaning it's implemented completely on the app side, and you can't provide a complete proof that a message was deleted. So that's a question for the implementers of applications using the software, which is us with the XX Messenger. And I can't really talk about the planned feature set at the time. I want to get back to video conferencing a little bit, which is that we have more that we're going to talk about in the future about high bandwidth private applications, but we're not ready to discuss that yet. The other question we have is how much is it costing to run a node on Amazon per month so far? So I think Jake has the numbers in front of him, but I want to point out that the nodes in the AlphaNet are different than the ones in the Beta Net in that they just use CPUs. So we've got these 18-core Intel Xenon processors, at least the ones from AWS, and which is going to be very different. The actual Beta Net nodes will strictly be consumer hardware, which will significantly reduce the cost, and also because they're doing most of the work on GPUs, it'll use significantly less power. So Jake, do you mind providing some numbers on the current costs?
Yeah, absolutely. So at the moment, to run the entire software stack, which for a node, which includes like a small database instance, a small gateway server, and then the 18/36 core machines, the price actually depends primarily on what region of the world that the server is located in. But with the current recommended specifications included with AWS deployment, the costs vary between $1,200 and about $1,900 per month, depending on, again, most importantly, where the node is physically located, as prices vary significantly through AWS depending on region. And I think that about covers that. Did you have anything else to add, Ben, or I was gonna?
No, I think we should hand it back over to Peter.
Sounds
Great.
good.
Yeah, and Jake, so again, those are prices based on the configuration for the AlphaNet, and you expect that the Beta Net configuration is going to be a lot more economical. Is that correct?
Substantially so. We're already knee deep in sort of working to allow our nodes to utilize GPU resources, which for our purposes is a much cheaper source of computational power. So as that begins to sort of make its way into the system, the node specifications will change slightly, and along with that, we will almost certainly no longer require such beefy CPUs, which is sort of the primary cost limitation in terms of creating and managing nodes.
Great, thank you, Jake. And so, yeah, I mean, again, one of the hats that I wear here is helping to communicate with the nodes. And so as we get ready to launch the Beta Net, which should be early next year, we'll be publishing a finalized set of specifications for those node operators and giving them a timeline for when they're going to need to make those purchases and spin them up. And so we think it's going to be pretty similar to the draft specifications that we published way back in January. So there's another question here, and I'm not sure if Ben or Will might be better positioned to answer it, but an anonymous attendee asked, why are we using binary denominations for the XX coins?
Sorry about that. Just needed to unmute. It's a pretty good question. There isn't, anything particularly special about binary denominations other than they allow you to have kind of a flatter distribution of denominations for any specific value of payment that you're trying to make. So obviously, any payment you're trying to make can be done with one of each denomination. And that's really kind of the reason why we use them. I don't know if Ben has anything else to add to that.
Binary denominations tend to have more flatter distributions than things like the 1, 5, 10, 20 denominations that are used by the US government. It's not a huge change, but it does slightly improve the privacy properties. We covered a little details on in a blog post called the denomination of a latte, which is kind of a tongue-in-cheek analysis of transaction privacy.
Great. Thanks, Ben and Will. There's a question from Jericho asking how energy intensive do we expect block production to be, or just in terms of running a node in general?
Hi, this is Bernie. So we don't think it's going to be that energy intensive because we don't have proof of work. So the block production is actually very easy. The BP will just get transactions either from CMIX protocol or directly from clients, and it will validate the signatures, create a state update. It's all normal operations that any standard server needs to perform. The same applies for when you run a node. We have shown the graphics where we integrate CMIX and the consensus algorithm, and by combining the CPU and the GPU, we can kind of keep the node always occupied. But keep in mind always that this is never as energy intensive as a proof of work algorithm.
Great, thanks, Bernie. There's another question from Jericho asking about kind of routing here. So messages and financial transactions are intertwined only in CMIX, while the latter is the only one that's stored in the blockchain. Is it only financial transactions that are stored in the blockchain?
Also a great question. No, not necessarily. In fact, we have planned, I don't know that we've revealed it in any of these documents, but at the minimum, we will have commitments to messages on the blockchain. So, there would be the root of all the messages that were processed in a batch that would be supplied to consensus, and they would then include that in the next block. And so, if you go and take that root and send it to whoever sent the message, they can verify that the transaction was successfully processed by CMIX and that it made it through. So yeah, that's all we're going to talk about right now as far as, what else can be committed on the blockchain. But yeah, it is our goal to at least include messages as well as the financial transactions, or at least a commitment of the messages.
Great, thank you, Will. And there's a question, I think Jake might be the right person to answer here, and it's from Keith. And so he's asking, how long do undelivered messages live on the network? Is there a mechanism for retrieving these messages if they don't make it through, or what does that process look like?
Yeah, so at the moment, messages are configured across the board to remain on gateways for 30 days, at which point they're removed. And this sort of removal has to do with just making attempts to sort of protect the messages however possible. And part of that is making sure they aren't accessible by the outside world, permanently in any way, shape, or form. And that includes living on any sort of networked device outside of the client application. It's something that has been considered regarding the possibility of configuring this depending on what you as a user would like in terms of your sort of security guarantees and message protection. It's possible that could be something configurable in the future. If you didn't mind and say you wanted your messages left for a longer period of time, that may be possible to configure in the future. But for the time being and for the foreseeable future, that's being locked at 30 days just as sort of a reasonable middle ground for protecting the client messages.
Great, thank you, Jake. So it looks like there's one more question here, probably for Ben. And at this point, I'm looking at my watch. We're at almost an hour 45. And so I think this may be our last question for the evening here. But then we've got a question about the kind of speed and scalability discussion, especially around pre-computation from your slides earlier on. And the question is, if we have more people using the platform or the size of the batches grow, won't this make pre-computation last longer, and therefore won't finality take longer? And so doesn't this impact the speed and the scalability of the network?
Yes. So well, pre-computation occurs before messages are received. And the way it scales is that pre-computations take longer the more nodes on the network, and therefore the more teams that can be created. And this is designed so that these longer times only occur when there are more teams to fill up the increased time that pre-computations will take. So no, as more nodes are added and pre-computation takes longer, delivery times remain exactly the same. And the network scales increasing capacity without increasing latency, with very minimal impacts on latency and performance. There's some more details of this in the Elixir architecture brief, but yeah, that's essentially the deal. Pre-computation does not is not impacted as latency or have an effect on finality as experienced.
Great, thank you, Ben. And again, thanks to everyone who's joined this presentation live. We'll be posting it to the Praxis YouTube channel soon. And then we'll also be covering the same topic next Tuesday. I believe it is 2 p.m. GMT, which will be a morning time for folks in the Western Hemisphere, afternoon and evening for folks in the Eastern Hemisphere. And Ben's last response there about how do we grow the network with nodes, that actually gets into the topic of governance. And so the third set of 2 webinars starting a week from right now will be focused on the question of token economics and governance. And so we encourage you to join that webinar as well. So in conclusion, our goal for this webinar this evening was to sort of bridge the gap between a more high-level overview of the XX network and simply telling people, oh heck, go read these white papers. And so we'd also appreciate your feedback on how well we've kind of walked that balance, where again, our goal for creating a truly decentralized network is to provide an explanation of this technology that can be grasped by as many people as possible. And so thank you so much for your questions and your feedback, helping us to try to achieve that goal. Thank you so much for joining this evening, and we look forward to seeing you at a future webinar. And also finally, please continue the conversation, especially on our Discord and our Telegram channels. There should be links to those on the Elixir and Praxis websites. So thank you very much. Have a great day.